Hi, I'm Kevin Collier, and today I want to talk about my implementation in the Unity 3D Kit game demo using Wwise. My goal with this project was to create something that had a lot of moving parts and interactivity in Wwise. So to help me keep track of everything, I created this extremely professional Microsoft Paint session. If you're interested in how I incorporated music theory into my audio design and would like to skip straight to that, check the timestamps in the video for player character sounds and the boss. To get started, let's look at how the ambiances work. I started by making big collider boxes that encapsulated each specific area I wanted to have its own ambience. Switching from one into the next triggers a fade between the current ambient zone and the next. Each collider is also set up with an AK environment zone using various auxiliary buses to give each space reverb. In the marshy area, I added a Wwise ambient event to the river, and then I used a handful of Wwise large mode positioner nodes to give the river soundscape a little bit more presence in the world. I used a blend container on the river ambiances to switch several audio tracks around. As you get close to the water, you'll hear frogs and moving water, but as you back away, you'll only hear a light trickle in the distance. I also added a collection of bird calls to the greater marshy swamp area. These calls are set in a random container that loops, but has randomized initial delay and transition delay. I also added a selection of automated emitters to make the bird calls feel like they were coming from somewhere in the space. Along with these ambiances, I added various states to an interior room, the pause menu, and the boss fight that lower the volume of the ambiances, add low-pass filters, or send the wind gusts to a virtual voice. In the temple area, I added several wind gusts that are also tied to a blend container. These wind gusts range from weak, quiet bursts with large amounts of time between them to long-lasting, loud gusts. I tied an in-game parameter to this blend container based on the player's Y value. To do this, I made a script that uses a map range clamp feature to track the player's Y value of the lowest point in the temple to the highest and set it proportionately from 0 to 1. In-game feedback for when the player takes damage is important. The audio plays a big role in showing how your in-game character is holding up. In Wwise, I created a handful of game syncs to help control this important information. I made a player health switch group and two parameters named player health and low health timer. First up is the player health switch group. But before I start, it's important that you know that I absolutely love music theory, and implementing it into game audio is a fantastic way to help share important information. I took this fantasy world the player finds themselves in as inspiration to add a tonal aspect to the main weapon swing. I tied this tone to the player's health, so when the player is at full health, it plays through an F major 7 quadrad. As the player loses health, specific pitches will fall a half step, thus changing the tonality of the chord from an F major 7 to F7 to F minor 7 to F minor 7 flat 5 and finally to F diminished 7. Each of these chords sounds slightly more dissonant than the last, which helps indicate to the player that their health is dwindling. Alongside my music theory-based sound design, I also added some more in-the-moment aspects to the player's health audio feedback. I used the player health parameter in conjunction with the low health timer to control a random container of heartbeat sounds, volume, and pitch. Using C#, I set the value of these parameters in Unity to specific intervals based on the player's health after they take damage. Taking damage triggers a timer that counts down. When this timer ends, a stop heartbeat event is triggered and the heartbeat stops. This timer is also used as the value for the heartbeat timer parameter in Wwise. As the timer lowers, the heartbeat's volume also decreases. Using this timer, I made it so that when the player has less health left, the heartbeat timer is set to a larger value, making it so you hear the heartbeat both louder and for longer. The player health parameter is also set when the player takes damage. This game sync is tied to the heartbeat's pitch. The lower the health, the higher the pitch. I've also set up a switch of player breathing sounds that corresponds to the player taking damage. This is tied to the same switch group as the player's weapon swings. The less health the player has, the more intense the breathing. When the player has only 1 health left, a new state is triggered, which adds a low-pass filter to the overarching sound effect audio bus. This is then removed when the player's force field ends. Finally, the boss. My goal with the boss was to create something menacing but also musical, just like the player's weapon. Starting with more music theory madness, I tied 2 tonal pitches from a wine glass to the boss's grenade bounce. I wanted these pitches to create an interval on each bounce that would grow more and more dissonant with each hit. I grabbed a loose leaf of paper and wrote out several groupings of 4 notes and the intervals between them. Each group of intervals starts on the higher pitch than the last to create a feeling of forward movement. In Wwise, I created 3 blend containers, 1 for each successive bounce. Each blend container has 2 random containers named like B1, P1, Bounce 1, and Pitch 1. I took the notes from the Pitch 1 and Pitch 2 groupings on my page and added them to their respective random container. Once Wwise's Avoid Repeating Last option is turned off, each blend container can give 4 variations using the 4 pitches between the 2 random containers. I put all of these blend containers into another parent blend container and tied a fade to an in-game parameter named Grenade Bounce Count. In Unity, when the grenade detects a collision that's not the boss itself, I add 1 to an in-game float named Number of Bounces. This float is tied to the Grenade Bounce Count parameter and set back to 0 when the grenade explodes. This helps me control when the playlist is reset and avoids any repeating instances of the bounces. Wow, that was a lot. Did I mention I really like music theory? Anyways, outside of my music theory use, I added several more parameters to the boss's grenade. When the grenade spawns, it carries a loop on it. This loop slowly rises in pitch with the timer. The starting pitch of this loop is randomized. This loop helps the player know where the ball could be using only audio cues. I also added a tremolo to the grenade's loop, which is tied to the grenade's Y value. I created a similar script to my map range clamped on the player character, but I tied this one to the tremolo's depth and mix. The lower to the earth the ball is, the more tremolo you will hear. The ball tends to explode closer to the ground, so this gives yet another audio cue to the player to know when the ball will explode. Outside of all of the orb's parameters, the boss's animations themselves, as well as the player and various other monsters in the level, have all been tagged to have their own sounds. Thank you for taking the time to listen to my audio and to listen to me talk about my music theory obsession. I hope you enjoyed my sound.